Hi guys, tonight we're exploring a gradual but catastrophic transformation. What if Earth's rotation began slowing down, then reversed direction entirely? Imagine the sun starting to rise in the west after spinning eastward for 4 billion years. If you enjoy these planetary catastrophe sleep stories, hit that like button and subscribe for more, and drop a comment letting me know what time it is where you are and where you're listening from. It's always great hearing from viewers around the spinning globe. Alright, let's begin. Imagine waking up tomorrow morning to find the sun rising in the west. Not suddenly, not violently, but as part of a gradual transformation that began months ago, so subtle that most people dismiss the early signs as measurement errors or optical illusions. Picture the growing confusion as astronomers worldwide frantically recalibrate their instruments, discovering that our planet's rotation, which has spun eastward at approximately 1,040 miles per hour at the equator for over 4 billion years, has begun to slow down. Day by day, hour by hour, the Earth's angular momentum decreases until that moment when our world stops spinning entirely, suspended in perfect stillness for a brief, terrifying instant before beginning to rotate in the opposite direction. This is not the premise of a science fiction thriller, but a thought experiment that reveals the intricate, delicate balance upon which all life on Earth depends. The reversal of our planet's rotation would unleash a cascade of consequences so profound and far-reaching that they would reshape every aspect of existence on this world, from the microscopic bacteria in ocean depths to the sprawling megacities that house our 8 billion human inhabitants. The initial signs of this planetary transformation would emerge in the most unexpected places. Deep beneath the streets of London, in the precision laboratories where atomic clocks measure time to within billionths of a second, scientists would notice the first anomalies. These instruments, which rely on the Earth's rotation to maintain their incredible accuracy, would begin showing discrepancies that couldn't be explained by normal variations. In Tokyo, the massive pendulum in the Earthquake Research Center would start exhibiting strange behavior, its oscillations gradually shifting as the Coriolis effect, that invisible force born from our planet's rotation, begins to weaken. Weather stations across the globe would register the early atmospheric changes long before the average person noticed anything amiss. The jet streams, those powerful rivers of air that circle our planet at altitudes of 6 to 9 miles, derive their strength from the temperature difference between the equator and poles, combined with the Coriolis effect. As Earth's rotation slows, these streams would begin to weaken and meander, creating bizarre weather patterns. Meteorologists in Chicago might observe winter storms arriving from the south, while their colleagues in Sydney track tropical cyclones spinning in the wrong direction. The most dramatic and immediate consequences would unfold across our oceans, which contain approximately 1.4 billion cubic kilometers of water. This vast mass of liquid, currently held in dynamic equilibrium by gravitational forces and rotational momentum, would begin to redistribute as the planet's spin changes. The equatorial bulge, that slight widening of Earth's diameter at its middle caused by centrifugal force, measures roughly 27 miles greater than the polar diameter. As rotation slows and eventually reverses, this bulge would gradually shift, causing sea levels to rise dramatically in some regions while falling catastrophically in others. Coastal cities like Miami, currently sitting just 6 feet above sea level, would face unprecedented flooding as millions of gallons of seawater redistribute across the planet's surface. The Maldives, already vulnerable with their highest point just 8 feet above the waves, would disappear entirely beneath the changing waters. Conversely, regions near the poles would experience massive water withdrawal, exposing millions of square miles of previously submerged ocean floor. The human cost would be staggering. Approximately 2.4 billion people live within 60 miles of a coastline. Their homes, businesses, and entire civilizations built upon the assumption that sea levels would remain relatively stable. In Bangladesh, where 21 million people live less than 3 feet above sea level, the rising waters would create the largest refugee crisis in human history. The economic implications alone would dwarf any previous disaster, with coastal infrastructure valued in the trillions of dollars suddenly rendered worthless. But the oceanic changes would extend far beyond simple redistribution of water. The great ocean currents that regulate our planet's climate, from the Gulf Stream that carries 30 million cubic meters of warm water per second northward along the American coast, to the Antarctic circumpolar current that transports 600 times the flow of the Amazon River, all depend on the Coriolis effect generated by Earth's rotation. As this force weakens and reverses, these massive conveyor belts of heat and nutrients would slow, stop, and eventually begin flowing in opposite directions. The Gulf Stream's reversal would plunge Western Europe into a climate more similar to northern Canada. London, currently enjoying average January temperatures of 41 degrees Fahrenheit thanks to this warm current, would experience winter conditions resembling those of Winnipeg, where January averages hover around -4 degrees. The economic implications would be enormous, with heating costs in the United Kingdom alone increasing by an estimated £40 billion annually, while agricultural productivity would plummet across a region that currently feeds 67 million people. Meanwhile, the Amazon rainforest, that vast green lung containing approximately 10% of all known species on Earth, would face an entirely different challenge. The reversal of global wind patterns would alter precipitation cycles that have remained stable for millions of years. This ecosystem, which currently receives between 80 and 160 inches of rainfall annually, might experience severe drought conditions as weather patterns shift. The loss of even 20% of the Amazon's 4 million square miles would release approximately 50 billion tons of stored carbon into the atmosphere, accelerating climate change beyond any scenario currently modelled by scientists. The transformation of wind patterns would have equally dramatic effects on human civilization. The trade winds, which have powered maritime commerce for thousands of years and currently drive wind farms producing over 850 gigawatts of electricity globally, would weaken and eventually reverse direction. The Sahara Desert, which annually contributes 22,000 tons of phosphorus-rich dust to Amazon soils through easterly winds, would begin sending its mineral payload in the opposite direction, disrupting both South American agriculture and West African weather patterns. Cities built around prevailing wind patterns would face unprecedented challenges. San Francisco, where the famous fog rolls in from the Pacific due to consistent westerly winds, might become perpetually shrouded in different weather systems as atmospheric circulation reverses. The city's 39 hills, perfectly positioned to channel these historic wind patterns for natural cooling, would create entirely different microclimates as air begins flowing from new directions. Agriculture, the foundation of human civilization, would face disruption on a scale unprecedented in recorded history. Modern farming techniques, developed over centuries to work with predictable seasonal patterns and weather cycles, would suddenly become obsolete. The monsoon systems that bring life-giving water to 3 billion people across Asia would weaken and shift, potentially reversing entirely. India, where 70% of annual rainfall comes during monsoon season, supporting agriculture that feeds 1.4 billion people, would need to completely reimagine its food production systems. The consequences would extend to the smallest scales of life. Migratory species, from the Arctic tern that travels 44,000 miles annually between polar regions to the monarch butterfly populations that navigate 3,000 miles using magnetic fields and celestial cues, would find themselves completely disoriented. Sea turtles, which have used magnetic navigation to return to their birth beaches for over 100 million years, would lose this ancient guidance system as the planet's magnetic field fluctuates during the rotational transition. Perhaps most unsettling would be the changes to Earth's magnetic field itself. This invisible shield, generated by the motion of molten iron in our planet's outer core, deflects harmful solar radiation and cosmic particles that would otherwise sterilize our planet's surface. The magnetic field's strength, currently measuring about 25 to 65 microteslas at Earth's surface, would fluctuate wildly during rotational reversal. Satellite networks worth hundreds of billions of dollars would become vulnerable to increased radiation, while GPS systems providing navigation for everything from commercial aviation to ride-sharing apps would experience significant disruption. The International Space Station, orbiting 250 miles above Earth with its crew of 7 astronauts, would face unprecedented challenges as the planet's magnetic field weakens. Radiation exposure for the crew could increase by 300%, forcing evacuation protocols never before tested in the 53-year history of human spaceflight. Ground-based power grids, already vulnerable to solar storms, would experience cascading failures as increased radiation overwhelmed protective systems designed for current magnetic field strengths. Communication systems that connect our modern world would face systematic breakdown. The ionosphere, that electrically charged layer of atmosphere between 50 and 600 miles altitude that reflects radio waves around Earth's curvature, depends on the interaction between solar radiation and our magnetic field. Changes to these systems would disrupt everything from AM radio broadcasts to military communications, potentially isolating entire continents from global networks. The economic implications would dwarf any previous financial crisis. Global trade, currently valued at approximately $28 trillion annually, relies on predictable shipping routes optimized for prevailing winds and currents. Container ships, which carry 90% of global cargo using routes planned around current weather patterns, would need completely new navigation strategies. The shipping industry would face estimated costs of over $500 billion just to adapt existing vessels and infrastructure to new oceanic conditions. Financial markets, increasingly interconnected and dependent on satellite communications, would experience unprecedented volatility as coordination between global exchanges becomes intermittent. The 3-second delay in electronic trading that currently occurs when signals travel from New York to London via submarine cables could become hours or days of complete communication blackout during magnetic field fluctuations. Yet within this chaos, human ingenuity would likely find remarkable adaptations. Architects and engineers would develop new construction techniques to accommodate reversed wind patterns and altered weather systems. The Netherlands, already world-renowned for water management with over 18,000 miles of dikes and levees, protecting land that houses 17 million people, would become a laboratory for innovative coastal protection strategies as other nations face similar challenges. Renewable energy systems would require complete redesign, but could emerge stronger than before. Solar panels, largely unaffected by wind pattern changes, might see accelerated adoption as wind power becomes unreliable during the transition period. Geothermal energy, drawing from Earth's core heat that generates 44 trillion watts of power, could provide stable electricity as surface conditions fluctuate. Agricultural innovation would accelerate dramatically. Vertical farming systems, already producing crops using 95% less water than traditional methods in controlled environments, would become essential as outdoor growing conditions become unpredictable. Genetic modification techniques could develop crop varieties adapted to new rainfall patterns and temperature ranges within decades, rather than the centuries required for natural adaptation. the social and political consequences would be equally profound. Migration patterns that have shaped human civilization for millennia would reverse as climate zones shift. The Sahel region of Africa, currently experiencing desertification that displaces millions annually, might become more habitable while Mediterranean climates could shift toward desert conditions. Entire nations might need to relocate populations, creating political challenges that would require unprecedented international cooperation. Religious and cultural traditions built around celestial observations would face fundamental challenges. Islamic prayer times, currently calculated based on the sun's traditional east-to-west movement, would need theological interpretation for a world where sunrise occurs in the west. Aboriginal Australian cultures, whose Dreamtime stories encode 40,000 years of celestial navigation knowledge, would need to adapt ancient wisdom to new astronomical realities. Scientists estimate that the physical process of rotational reversal would unfold over several decades, possibly centuries, depending on the underlying cause. If triggered by internal geological processes such as changes in Earth's molten core dynamics, the transition might take 500 to 1,000 years. However, if caused by external forces, such as gravitational interactions with a massive celestial object, the change could occur much more rapidly, perhaps within 50 to 100 years. During the transition period, days would gradually become longer as Earth's rotation slows. Currently, our planet completes one rotation in exactly 23 hours, 56 minutes, and 4 seconds. As rotation decelerated, days might extend to 25, then 30 hours before reaching the standstill point. This gradual increase would disrupt circadian rhythms that govern not just human sleep cycles, but the biological functions of virtually every living organism on Earth. Plants, which have evolved sophisticated internal clocks synchronized to 24-hour cycles, would struggle to adapt to changing day lengths. Photosynthesis efficiency would decrease as light exposure periods extend beyond optimal ranges, potentially reducing global food production by 20 to 30% during the transition decades. Night-blooming flowers that rely on precise timing for pollination would find themselves opening at the wrong moments, disrupting entire ecosystems. The psychological impact on human populations would be immense. Sleep disorders would become epidemic as our bodies struggle to adapt to ever-changing day-night cycles. Seasonal affective disorder, currently affecting approximately 5% of adults in higher latitudes, would likely increase dramatically as traditional seasonal light patterns disappear. Mental health systems, already strained in many countries, would need massive expansion to address widespread circadian rhythm disruption affecting billions of people. Emergency services would face unprecedented coordination challenges. The current system of global time zones, established in 1884 to facilitate railroad scheduling and now essential for international commerce and communication, would become meaningless as different regions experience wildly varying day lengths during the transition. Air traffic control systems, managing over 100,000 flights daily worldwide, would need complete redesign to navigate a world where traditional navigation references no longer apply. The reversal would also reveal hidden aspects of our planet's history. As ocean currents change and water levels fluctuate, previously submerged archaeological sites would emerge while others disappear forever beneath new seas. Coastlines that have remained stable for thousands of years would shift, potentially exposing evidence of ancient civilizations or destroying irreplaceable historical sites. The ancient city of Venice, already struggling with aqua alta flooding that occurs approximately 100 days per year, might find itself permanently submerged or, conversely, stranded inland as Adriatic sea levels change. Scientific research would accelerate in unprecedented ways as researchers race to understand and adapt to changing conditions. climate models that currently project weather patterns decades in advance would become obsolete overnight, requiring entirely new computational approaches. The European Centre for Medium-Range Weather Forecasts, which processes over 40 billion observations daily to predict global weather, would need to rebuild forecasting systems from fundamental principles. Paleoclimatologists would gain invaluable insights into Earth's deep history by observing rotational reversal in real time. Previous episodes of geomagnetic reversal, which occur approximately every 450,000 years based on geological records, left only indirect evidence in rock formations and ice cores. Witnessing the complete process would provide unprecedented understanding of how our planet's systems interact during such dramatic transitions. The space exploration implications would be equally significant. Current mission planning to Mars relies on precise orbital mechanics calculations that assume Earth's continued eastward rotation. The European Space Agency's planned Mars sample return mission, scheduled for the 20s with a budget of €7 billion, would need complete recalculation as launch windows and trajectory requirements change. Similarly, the James Webb Space Telescope, positioned at the Lagrange point 1.5 million kilometers from Earth, might require repositioning as gravitational balance points shift. Satellite constellations providing internet connectivity to remote regions would face systematic replacement. Starlink's current network of over 5,000 satellites, orbiting at altitudes of 340 to 614 kilometers, relies on precise orbital mechanics that would be disrupted by changing rotational forces. The estimated cost of replacing or repositioning these satellites could exceed $100 billion, creating questions about whether global internet connectivity could be maintained during the transition period. Yet perhaps the most profound changes would occur in ways we cannot fully anticipate. The Earth's rotation has been a constant throughout the entire evolution of life on our planet, shaping everything from the spiral structure of nautilus shells to the migration patterns of whales. Every biological process, from the cellular level to the ecosystem level, has evolved assuming eastward rotation and its associated Coriolis effects. Consider the implications for weather phenomena we take for granted. Hurricanes in the northern hemisphere currently rotate counterclockwise due to Coriolis forces, while their southern hemisphere counterparts spin clockwise. During rotational reversal, these massive storm systems might lose their characteristic spiral structure entirely, becoming chaotic and unpredictable in ways that current meteorological models cannot describe. The eye wall of a Category 5 hurricane, where winds exceed 157 miles per hour, might dissipate into scattered storm cells, or conversely, intensify beyond any previously recorded storm strength. Tornadoes, those violent rotating columns of air that occur most frequently in the central United States, with an average of over 1,000 per year, depend on wind shear patterns created by continental-scale air movement. As global wind patterns reverse, tornado activity might migrate to entirely different regions, or increase dramatically in areas that have never experienced such storms. The economic impact on insurance markets alone would be staggering, as risk models developed over centuries of stable weather patterns would become useless. The Great Pacific Garbage Patch, that massive accumulation of plastic debris spanning twice the size of Texas in the North Pacific, would likely disperse as ocean currents change direction. While this might seem beneficial, the redistribution would spread microplastics to previously pristine marine environments, potentially contaminating food webs that have remained relatively unaffected by human pollution. Deep ocean ecosystems, home to countless species that have never been fully catalogued by science, would face disruption as thermal layers and chemical gradients shift with changing current patterns. The deep-sea vents that support unique biological communities, powered by chemosynthesis in the absence of sunlight, might find their chemical supplies altered as mineral-rich water circulation changes. These isolated ecosystems, which have provided insights into the origins of life itself, could be lost forever before scientists fully understand their biological significance. The consequences would extend to the very foundations of timekeeping that govern modern society. Atomic clocks, accurate to within 1 second over 300 million years, would need recalibration as the fundamental reference points of rotation-based time measurement change. The Global Positioning System, which provides location accuracy within 3 to 5 meters for billions of users worldwide, depends on precise timing coordination between 24 satellites. As Earth's rotation changes, the entire system would require recalibration, potentially creating navigation chaos for weeks or months during critical transition periods. International law would face unprecedented challenges as territorial boundaries defined by latitude and longitude lose their precision. Maritime boundaries, crucial for fishing rights and undersea resource extraction, would need renegotiation as coastal geography changes. The Arctic Ocean, currently experiencing increased international attention as ice melts, reveal potential oil reserves estimated at 90 billion barrels, would face entirely new geopolitical dynamics as ice formation patterns change with altered ocean currents. Food security would become a primary concern as agricultural regions worldwide face unprecedented conditions. The breadbasket regions of the American Midwest, which currently produce approximately 40% of global corn and 35% of global soybeans, would likely experience dramatically different precipitation patterns. Similarly, Ukraine's fertile agricultural region, responsible for 12% of global wheat exports before recent conflicts, might find its black soil either parched by drought or waterlogged by excessive rainfall as weather patterns shift. The wine industry, with its deep connections to specific regional climates developed over centuries, would face complete transformation. Champagne's unique terroir, protected by European law and dependent on precise temperature and rainfall patterns in northeastern France, might become unsuitable for traditional grape varieties. Conversely, regions currently too cold for viticulture, such as southern England or northern Germany, might become premier wine-producing areas as climate zones shift northward. Urban planning would require revolutionary approaches as cities designed around prevailing wind patterns face entirely new environmental conditions. Chicago's famous wind patterns, which earned it the nickname Windy City, would reverse as atmospheric circulation changes. The city's architecture, from skyscraper orientations designed to minimize wind stress to park layouts optimized for natural ventilation, would need fundamental reconsideration. Public health systems would confront challenges unlike anything in medical history. Vector-borne diseases that spread through specific climate conditions would likely migrate to new regions as temperature and precipitation patterns shift. Malaria-carrying mosquitoes, currently restricted by temperature limits to tropical and subtropical regions, affecting approximately 3 billion people, might expand their range as climate zones shift, while simultaneously disappearing from traditional endemic areas. The psychological adaptation would prove equally challenging as the physical changes. Humans have used celestial navigation and solar patterns for orientation throughout our species' history. The simple act of determining direction by observing sunrise and sunset positions would require complete relearning. Cultural traditions built around astronomical events, from harvest festivals timed to seasonal changes to religious observances based on lunar and solar cycles, would need fundamental reinterpretation. Perhaps most remarkable would be the emergence of new cultural and scientific perspectives, born from witnessing our planet transform in ways previously unimaginable. The experience would likely catalyze unprecedented international cooperation, as humanity faces challenges that transcend national boundaries. Climate engineering projects that seem impossible today, such as large-scale atmospheric modification or controlled ocean current redirection, might become essential survival strategies developed through collaborative effort. The reversal of Earth's rotation would ultimately reveal the profound interconnectedness of every system on our planet, from the microscopic to the global scale. It would demonstrate how the most basic assumptions about our physical environment shape every aspect of life, from the cellular mechanisms that govern our bodies to the economic systems that structure our societies. In facing such a transformation, humanity would likely discover capabilities for adaptation and innovation that surpass our current understanding, while simultaneously gaining a deeper appreciation for the delicate stability that has allowed civilization to flourish on this remarkable planet spinning through space. This thought experiment illuminates not just the consequences of rotational reversal, but the extraordinary complexity and interconnectedness of Earth's systems that we often take for granted. Every aspect of life as we know it depends on the continued eastward spin of our planet, that fundamental motion that has remained constant throughout the entire history of complex life on Earth. Understanding these dependencies reveals both our vulnerability and our remarkable capacity for adaptation when faced with seemingly impossible challenges.